Hi, this video is part 3 of composite functions, and we're going to pick up where we left off. We just learned how to evaluate composite functions using a table and then using a graph. Now we're going to do the same thing but using a formula. So, given a formula for a composite function, evaluate the function. To do this, we're going to evaluate the inside of the function using the input value or variable provided, and then using the resulting output as the input to the outside function. So basically what that means is we're going to work inside out, and we're going to do basically two separate problems. So first we have the following functions. F of t is equal to t squared minus t. And then we also have the function h of x equals 3x plus 2. So we want to find h of f of 2. So what we're going to do is we're going to start by finding this inside part here, this f of 2. That's what we're going to do first. So let's find f of 2. So that is where we take the function f of t and we rewrite it t squared minus t, and everywhere we had a t we're going to insert 2 inside parentheses, and then we're just going to solve it. So f of 2 equals 2 squared, which is 4, minus 2, which is 2. So f of 2 equals 2. What that means now is we're going to replace f of 2 with what it equals. It equals 2, and we're going to find h of 2. So now to find h of 2, we take the function h, which is 3x plus 2, and we're going to insert what it equaled, which was 2. And then we're going to solve it. So 3 times 2 is 6. 6 plus 2 is 8. So h of 2 is 8, which means h of f of 2 is equal to 8. Okay, so you guys pause the video and you try the next one, h of f of negative 2. And when you come back, we'll go over the answer. Okay, so hopefully you had a chance to try to work this on your own. So h of f of negative 2. So we're going to start by finding f of negative 2. And f is t squared minus t. And everywhere I see an x, I put a parenthesis. And inside the parenthesis, I'm going to put negative 2. So this one, negative 2 squared is positive 4. And then here, negative becomes a plus. So f of negative 2 is equal to 6. So now we're going to find h at 6. So h was 3x plus 2, and instead of the x I use parentheses, and in the parentheses I'm going to put 6. So now h of 6 is equal to 3 times 6, which is 18, and 18 plus 2 is 20. And that's as far as we can go there. Alright, great job. So now let's talk about finding the domain of a composite function. Okay, so we have talked about how to find domain of functions, but this is a composite function. So it's a function within a function. So it's a little bit more complicated. So first you're going to find the domain of the inside function. So if we're doing f of g of x, find the domain of g first, then find the domain of f. Once you find both of those, then you find those inputs x in the domain of g, for which g of x is in the domain of f. And what that means is we're going to exclude those input x's from the domain of g, for which g of x is not in the domain of f. So let me just show you how to do a couple of these. Okay, so we are finding the domain of f of g of x. Okay, so first, we're finding the domain of f of g of x. That's what that means. Okay, so we need to find the domain of the inside function. That's where we're going to start. So we're going to start at g of x, and we need to find the domain. Now, what we know about g of x is that it is rational. And if it's a rational function, the denominator cannot equal 0. The denominator cannot equal 0. So now we're going to solve that for x. So we're going to add 2 to both sides. And we'll get 3x cannot equal 2. And then we divide both sides by 3. And we get x cannot equal 2/3. Now that is only the domain of g. Okay, so now we need to find the domain of f. So okay, so for the domain of f of x, so now we're looking here, we know that x minus 1 cannot equal 0, because if it does, you'll get an undefined. So we're going to add 1 to both sides, and we find that x cannot equal 1. Now here's where it gets interesting. Domain for f of x, the x is really g of x. So what we're saying here is that x can't equal 1, but in this case x is g of x. So we can say 4 over 3x minus 2 can't equal 1. And then we have to solve. So this is a rational equation that we have to solve. So depending on how comfortable you are with this, I will explain it, and if you need further explanation, you might look up how to solve rational equations, because that's something you should know. I mean, I'm also happy to answer your questions, but just alerting you that this is something that we're supposed to know. So what we do is to get rid of, well, the x is kind of stuck in the denominator. So to undo that, we're going to multiply both sides by 3x minus 2. And what you do to one side, you do to the other. And what happens here is 3x minus 2's cancel, and that leaves 4. 4 cannot equal 1 times 3x minus 2, which is just 3x minus 2. Then we're going to add 2 to both sides, and we'll get 6 can't equal 3x. And let's see if I have any more space here. And then we divide both sides by 3. X can't equal 2. So for the domain, what we know is, now, this one we weren't finished with because we had to replace the x with what the g of x equaled. So this is where we're done with the f of x. So we know that x can't equal 2/3 and x can't equal 2. So it's all reals except 2/3, and 2. Now, if we want to write that in interval notation, it's all numbers from negative infinity to 2/3, union with all numbers between 2/3 and 2, union with all numbers between 2 and infinity. And what this shows is we have excluded 2/3 and we have excluded 2. Otherwise, it's all the other numbers on the number line. So that was fun, right? So find the domain of the inside function, in this case g of x, then find the domain of f of x, but then plug in g of x for x, if that makes sense. So in this case, I kind of did it in pieces, but you could have also went ahead and put this in there and solved. Okay, let's look at the next example. Find the domain of f of g of x, where f of x is equal to x and g of x is equal to 3 minus x. So first, we're going to start with g of x because that's the interior function, and we're going to find the domain. So for the domain of g of x, what we know is that the interior of this square root cannot be negative. So what that means is 3 minus x has to be greater than or equal to 0. So we're going to solve on both sides and subtract 3. We get negative x is greater than or equal to negative 3. Then we divide both sides by negative 1. And we get x is less than or equal to 3. And the reason it's less than is because I divided both sides by a negative number. So the domain of g of x is all real numbers that are less than or equal to 3. Now, for the f of x, we need to think of this in terms of f of g of x, which would be the square root of x, and the x is the square root of 3 minus x. And so what that means is the interior here has to be greater than or equal to 0. And if we solve that, we would square both sides, and then 3 minus x would be left on the left, 0 would be left on the right, and then this is very similar to this equation over here. Subtract 3, we get negative x is greater than or equal to negative 3. Divide by negative 1, and we get x is less than or equal to 3. So either way, we get x is less than or equal to 3, so all real numbers except that. All real numbers that are less than or equal to 3. And so to write that in interval notation, we would say negative infinity to 3, and because of this equal sign here, it does include 3. Alright, so you guys try this one. This one kind of, it combines the two types, and see how you do. Okay, hopefully you paused the video and you worked the problem out on your own. So we're doing f of g of x. So it looks like the interior, function is g of x. So we need to find the domain of that. So the domain of g of x is that we know that the interior here, x plus 4, has to be greater than or equal to 0 because it can't be negative. So if we solve that, we find out that x has to be greater than or equal to negative 4. So all real numbers that are greater than or equal to negative 4. Now, over here, for the f of x, we need to say that we need to really look at it this way. F of g of x is 1 over x. X is really the square root of x plus 4 because we're substituting g of x into it minus 2. And what we know is that this bottom, this square root of x plus 4 minus 2 can't equal 0. So then we solve. So we add 2, square root of x plus 4, this cancels, doesn't equal 2. Square both sides, square and does the square root, leaves x plus 4 equals 4. And then subtract 4 on both sides, we get x equals 0. Or, I'm sorry, not equal to 0. So, in this case, all real numbers that aren't equal to 0. But also, both have to be true. Both of those have to be true. So we kind of combine this. All real numbers greater than negative 4 except for 0. That's what that means. All numbers. We had a number line. Here's negative 4. It's all numbers greater than negative 4 except, oops. No, it doesn't want to let me just erase a little piece of it. So except here, 0. So that means that we're going to have a union. So we have from negative 4, including 4, to 0. And then from 0 to infinity. Okay, so again, what you want to do is find the domain of g of x, or the interior function, first. It's just in the 3 examples we did, g of x was the interior. So find the domain of the interior first, and then find the domain of the composite function, f of g of x, basically. And then both of those domains have to be true. So, now I will say in this one, we kind of bypassed a little bit, because when we did the f of g of x, we went ahead and found the domain of f of x here, and then set that equal to our g of x, and to try to break it down a little bit, but you could have plugged in g of x into f of x and then found that domain, and it would have worked out the same way. Okay, so that looks like we're finished with this section. So if you have questions, as always, let me know. And that's all for this one. So signing off.